Okay, good. We are recording. Hello, everyone. Um, so today we're going to talk about AI agents that are capable of reasoning, planning, and acting to accomplish goals. Before I start, I just want you guys to introduce yourself quickly. We are the team MOORCHEH AI, and we are building memory for AI agents. Let's go ahead. Uh,
Yeah, sure. My name is Neil, and I'm working as a software developer in Moorche, and we've been building this product, and we'll try. We're gonna move into the agent industry and going into there as a memory layer. So yeah, would like to forward to the help.
Hi everyone, my name is Hit, and I am also a software developer at MOORCHEH AI. We are working on creating something good for AI agents, which they're gonna like it. And yeah, so let's see where the conversation go today.
awesome.
Yeah, and my name is Rasa. I'm also a software developer. I just recently joined MOORCHEH last month,
Mhm.
and we are working hard on building this memory layer. We're hoping it does well in the AI space and can compete with other products that other people have.
Yeah, awesome. So I'm so proud. This is a small team, but a team that I really picked with a lot of attention.
Mm.
This is a very mighty team, highly motivated. But today we want to talk about like a bigger, higher picture, like why we're doing it, and the why also goes into um the reason we are doing it, but also the reason why this is such an important question for the entire industry of how to build AI agents. So let me start by sharing my um, presentation. And please feel free to comment, ask questions, and give me your opinion along the way.
Sure.
Because I wanted this to be a discussion, not just a monologue. Okay, excellent. Yeah. So yes, AI agents that reason, plan, and act to accomplish goals. And I want to talk about the practical aspects. Not just we give it to LLM and LLM does everything, but the practical engineering system. How do we build these kind of agents? So we talk about practical tools, real solution. There's no fluff in this. Okay. So the main reason why we are going to autonomy to give more autonomy to agents. And this graph shows how the autonomy of agents progressed over time. So at first, this was like a, let's say, chat GPT, and then we moved towards more tool calls, and now we have uh, automatic working agents, and now we're going to give more and more autonomy to agents. And the reason is that um, revenue generation by LLMs, it and the commercialization of them needs ROI. And the most obvious ROI is to give the agent task, and they can accomplish those tasks, and you can measure it with business outcomes. So they are becoming from an LLM that's calling the tools. We need to turn them into actual workers that are accomplishing jobs and working, and that's how the entire industry would justify the billions of dollars that's being spent into developing LLMs. Any questions so far? Yeah,
No, we're gonna.
good, good. And another uh, on the cost of LLMs, there's a big hidden cost to it. Um, I don't know what the titles are. Basically, going forward, we have uh, um, a lot of computation cost goes to subsidizing and obscuring the real infrastructure costs of AI. We have um, a lot of layers of security built in. Those consume tokens. We have errors and hallucination prevention methods that those also consume tokens. We have hidden contexts that are being wasted, and we have a lot of the tokens goes into the context window that is not fully relevant. So these are all places where we can reduce the cost of LLMs up to 50%. That's the opportunity. By sharpening the context, by sharpening the actual real outcome of the work. And a lot of the cost is already right now subsidized and people are getting used to it. For example, if you just pay $20 per month and you can run as many queries on ChatGPT and Gemini, it actually costs a lot more for these companies. If all the people who have subscribed keep using it on a daily basis for several hours, or have agents who are working on behalf of them, the cost would be massive. It's not
Yeah.
just $20 per month. It would be hundreds of dollars per day. So a lot of people don't know that these LLMs and tokens are very expensive on the back end, basically. So, but how these agents are supposed to work? They need to do three tiers of work. First, they have to be able to reason properly. They have to understand the goals, decompose the steps to get to the goals, identify constraints, evaluate knowledge gaps, and select the approach. Then they have to plan. So, and these are like big picture. So they have to sequence the subtasks, allocate resources, set checkpoints, and define fallbacks of any part. If it fails, what should I do, basically? And then on the act side, they have to execute step by step. They will be able to call the tools, observe the results, check for the failures and errors. And if the failure happens, goes to the loop to fix them. And at the end, they report so someone can audit and see what happened, what was the outcome.
Right.
And every step has to be traceable, auditable, and explainable. It cannot be a black box. Otherwise, because some part of it is already black, we cannot control them. At least we have to be able to go back and see what went wrong if something goes wrong. Now, another trend I was saying is that the more models become capable and intelligent, and the cost per capability units goes down, but we might reach some kind of plateau or bottleneck. And these plateaus and bottlenecks are constraints that we have to fix by the architecture of the AI. So the scaling so far in the intelligence has been by increasing the number of data and the training, massively increasing the scale of the data centers for training and inference. But there are some limitations to how much more intelligent these models can get. We're gonna hit some limits, I think, at some point. And to explain these bottlenecks is this is how I would argue this would be. I would say 40% is because of the our transformer architecture, because it's quadratic scaling, which means if you increase the token size and the context, it would need the square of that in the backend infrastructure. And there is, and the focus is also limited, and the focus goes down as you increase the context, and then the loops become more expensive, and they're not built inherently to be a recursive function. They're one-shot basic and linear progression, and all reasoning compressed into forward paths. Basically, everything goes forward in one direction. And there's also training limitations. Is how much data we've already used the entire internet to train these models. There will be synthetic data, but no one knows if this synthetic data would add substantial intelligence. And there is also the issue of catastrophic forgetting that's related to neural networks and how they work. And yeah, and then we have the inherent limitations in language, human language structure.
Mhm.
The human language is not designed for um, like engineering purposes by default. It's designed for like human communication and expression, even though it's a very powerful tool. But some of the ambiguity of the language is passed on to these models, so which makes them a little tricky in the architecture as mm, tools for engineering and construction.
Right.
So one of the differences between the biggest problem, I would say, if I want to make it concise into only two words, is the continuity of consciousness. And that's the main difference between a worker and an LLM agent. Okay, so we call them agent, and they're not workers yet. So I would say generating workers needs something else. Let's say a human worker wakes up in the morning, starts work, and does some research and planning, then executes the plan of the day and has a review of the day with what happened. And the next day when it comes, it continues that kind of work, repeats the same cycle by remembering, having a persistent memory and context and identity. That's how
Yeah.
you can carry a project for weeks and months or years with full continuity. And the issue with the LLM agents is we don't have that kind of continuity yet. So each call to LLM is a blank slate. Each call you make to LLM is a new, fresh context coming in on the LLM side. And just imagine if your memory gets deleted every morning
Yeah.
and you can't accomplish any work, like you can't accomplish
Yeah.
any
Yeah.
long-term work. And I would say that's the biggest problem.
Yeah.
Now, and then this was being another challenge. I would say this is the secondary challenge, not the first one, but still could become a big challenge going forward in the engineering aspect. As I mentioned, human language or natural language is not designed for formal logic. So in formal logic, you have mathematical precision, you have deterministic outcomes, and you can prove concepts and you can verify with machine. Uh, but in natural language, you have ambiguity, you have the meaning of context changing. Same words could mean many different things in different contexts. So you have the probabilistic, and you have human intuition that's designed to work with the human language, but machines don't have that intuition yet, and
Right.
its expressiveness is great. So the agents that win will bridge this gap, but not by choosing one side, but building a translation layer that still allows humans to interact with the worker in human language. But on the execution side, we have to develop a new kind of logic that is as close to as engineering and solid programming as possible. And then there is also the another issue, that's the attention paradox, what I call, um, and that's very intuitive to understand. Is that as the size of the context grows for LLMs, they lose focus. So there is a trade-off between the depth of focus and the breadth of knowledge that you hold at your hand. So you can, so example say you can't hold an entire book word by word in memory and also focus on a single concept. Actually, a human can do something like you can read the entire book and at the end
Yeah.
have some image, like some abstract image of what all this book represents to me. Or you can think of a story,
Yeah.
let's say a story of, let's say, Goethe's Faust, And so you tell a story. There's so many details, so many things happen. So, but at the end, you have an image of Faust. That's an abstract. So you can focus on a concept that has many layers.
Yeah.
But then for LLM, the depth does not exist. It just works with the immediate uh, language components of words that's dealing with. So the focus is now. But if you put LLM with RAG, you can give it direction in terms of knowledge and focus. You sharpen the focus even more. But hopefully, the ideal agents plus memory would be able to hold a very vast knowledge and at the same time being able to focus on what's necessary at the moment
Right.
for the task. So the more context and less context. So we need a solution that solves this trade-off. So what? And then humans are capable of doing abstractions, and a lot of human capability comes from uh, going from raw data into actionable insights. So humans can detect the patterns, recurrent relationships, and correlations, and they reuse the models they learned before on a conceptual level, and then that leads to actionable insights. Um, so if there could be a model that can do the abstraction and compression the same way that the human does, it would be a good for step forward. Now, but today LLMs flatten everything to the same level. For LLM, everything is flat. Everything is just a face value language, immediate, anything that is in the context, and that's it. Mm, but agents definitely need a hierarchy of abstraction uh, because they won't be able to prioritize and discern what matters now or what doesn't matter, basically. Uh, which is even more important than what matters is what should I ignore at the moment?
Yeah.
What should I focus on? Now I have this conceptual graph. Like if you imagine that um, so the storage you can hold structure, weighted contextual recall. Right now, the current RAG is only good at bringing back the relevant concepts, but they should be able to track provenance, attach importance scores, and maintain relative urgency and preserve continuity across sessions and forget gracefully. So being able to focus, forget, abstraction, all of these are capabilities that agent memories must have. So now I summarize the whole thing, going from most important challenges to the solutions engineering. So the ability of abstract thinking, being able to organize and compress information into operational concepts, see the forest and the trees. So memory has to be hierarchical. It has to be concept extraction, and then logical deduction from that. That's how reasoning chains work. There is a lot of good advancement in reasoning. So we have reasoning models, which means that there was a demand and there was a solution provided, but we don't have like a symbolic solvers. I don't know if you guys remember, but there was some mathematical tools called Maple. It was developed like, actually, it was you gave it an equation, it would solve it symbolically for you. We need symbolic solvers for um, LLM logics. And I don't think anyone has done that, which can prove or disprove and discern based on certain uh, constraints that are engineered into its logic. And then finally, persistence of memory, persistence of identity, and continuous, continued or non-interrupted um, consciousness, basically, is the ultimate goal. And that can be actually achieved by tricks. It's not so we know that LLMs at the end are just responding to what comes in, but if we design it properly, we can simulate a well-structured LLM that knows what's important, knows what's the provenance, knows what's coming from, and those will be the art and engineering of the memory. So our practical thing, I don't have much time left, but we can talk about this next time on the ideas. I have some ideas here, but we can talk about that more in detail, and also the actual practical solutions that we are putting into MOORCHEH memory layer, or MUMLA, that's coming out. And we need to think about our roadmap going forward. And we have done some of it. So we already have a well-structured, imposing a structured input intake of memory. Because of the architecture of MOORCHEH, it's very well designed to take in JSON formats and JSON schemas, and being able to filter based on those metadata on the JSON format. So you have the full freedom of designing different kind of schemas, and there's that flexibility is built into the infrastructure. And it's also agentic, so you can call for intelligence whenever needed. And have proper error handling and a good working Python SDK that supports all of that. And then we need this looping cycles. We need these observation, and we need these daily summaries and session summaries, and then audits. And that's where the persistent comes in. We still have to work on importance scoring. We have a very good relevance scoring method, which can become a tool for importance. So we can translate relevance. So if you know what is important, basically, and we have a concept, we say this is the most important concept, and then we measure the relevance of everything to that core concept, we can actually measure the importance. Right?
Yeah, kind of a nodes around the one center nodes.
Yeah. And because information theoretic score is kind of a universal score, right. And it's always between 0 and 1, very well tuned and very well behaved, we can rely on that, on the importance. And then session continuity is a problem of engineering. And then we need verification layer and some of those guardrails, conflict resolution, and timelines, and symbolic checks and proofs would be going into that final layer. So all together, it would be moving towards building memories for chatbots to become autonomous agents and actual workers. Yeah, and I believe that the future is not about making models smarter and smarter, even though they are becoming smarter. But I think at some point, the new breakthroughs would happen through the architectures and integrating these LLMs, everything that we have so far. How do we integrate them into an engineering structure that they can work? And memory continuity, logical deduction, and abstract thinking. And we can give those additional gifts to AI, so that it becomes capable of reasoning, planning, and acting to accomplish goals. Yeah, that's my presentation. And do you guys have any comments you want to add? Anything?
And I've been thinking about like how we sort of making comparisons to human memory, and we're thinking of how the human memory system operates and how we remember context like a small paragraph from like a whole book. They're almost trying to imitate like how neural networks, we are trying to sort of imitate how neurons are firing in the brain. And now we're trying to do the same for attention.
Yeah, Yes, it's a tricky question. I say an analogy, let's say. So humans wanted to design a flying machine for a very long time in the history, okay? And the most obvious examples they had in nature was birds and insects. And they have wings that goes up and
Yeah.
down, right? But
Mhm.
eventually when humans actually solved the engineering problems and they created airplanes, they have wings, but the solution was not to flap them the same way that the nature solves it. Okay?
Right.
So now taking analogy, we know that like human brain solves it in a particular way, uh, but the AI engineering, like the engineering solution, does not have to be exactly the same. The same way, like we're gonna have some form of abstraction and some form of logic, and deduction, and focus mechanism. But they, I think, that's in my opinion, they will differ from how humans do it. But
Yeah.
we can get inspiration from uh, uh, human intelligence, uh, but not copying it to the T.
Yeah.
And the same thing applies to the design of the neural networks. We call them neural networks, but they have nothing similar to the mechanism of actual neurons in the brain, because the neurons actually would work with pulses, electric pulses, but these what we call neural networks in AI today um, is not similar. It's not same mechanism at all. Yeah, but good point. Okay. All right. Okay, we are on time. Exactly 30. I don't want to go more than 30 minutes. So thank you very much, and thanks to the people who are watching the video. Please reach out to us to join our Discord channel. I
Mhm.
put the link in below, and join us and help us build this memory layer and agents that turn into workers.
Yep.
All right.
Yeah.
All right.
Thank you.
Yeah. Thank you.
Bye.
Bye.
Okay, bye.
But
Bye.